Okay, we're going to start going over problems 28, 29, and 30 of the 2018 geometry exam. All right, so let's go ahead and read the question. So take a second and read the question, and I'll be right back. Okay, now hopefully you've read the question, and it says, I'm going to read it again. In the diagram below, the circle has a radius, first keyword, radius, of 25 inches. The area of the unshaded sector, that's another keyword, is 500 pi inches squared. And let's look at our question, what we actually have to answer. It says, determine and state the degree measure of angle Q, that's this angle here, the central angle, there's another keyword, of the shaded sector. All right, so there's some keywords. I want you to write down some vocabulary here. And I'm going to put up some stuff. So we need to know the definition of a sector. We need to know the definition of a central angle. And let's see here. So write those down. We also need to know the formula for the area of a circle. That's right here. And number of degrees in a circle is 360. So all these things are going to come into play. Here's just a little picture here. All right, all of these are going to come into play. So take a second, pause the video, write those definitions, formulas, everything down. Okay? All right, so what I'm going to do, it actually tells you the area of the unshaded sector. So the unshaded sector would be what I am outlining in red, okay? And the shaded sector obviously is the other part. Now, what I think would be helpful in this case is to find the area of the entire circle. So let's go ahead and do that. The area formula is pi r squared, so it's going to be pi times 25 squared. And the area is going to be, let's see, 625. So 625 pi units here, right? Is this inches, or really doesn't matter, but yeah, so pi inches squared, right? Okay. And we need to find the measure of angle Q. So again, the angle Q is a central angle. That's a central angle here. And I'll just highlight it for us. Okay? A central angle is formed by the two radii, or by two radii rather, with a vertex being at the center of the circle. So that's obviously what we have here. We have a central angle, right? Now, I want to think about this. So the entire circle has an area of 625, right? Pi, 625 pi. The shaded part has an area of 500 pi inches squared. So that means, how are we going to figure out the area of the shaded part? Because that might be helpful. Let's do that. So what we found in red was the area of the whole. All right, so that means the area of the shaded part, so we have the area of the whole, the area of the unshaded part, so area of unshaded part is equal to 500 pi. All right, so that means the area of the shaded part, so the area of shaded, area of the shaded part is equal to 625 pi minus 500 pi. All right, and that's going to be 125 pi. Okay, now that's the area of the shaded part. So the area of the shaded part is 125 pi. The more important part, though, is what percentage or what fractional part of the circle is the shaded part. So this shaded part in green, what fractional part is that? Well, we know it's 125 pi. And if we divide that by the whole, which is 625 pi, we end up having those cross out, the pi's cross out. And once you do that, you end up with 1/5. So the point is that green shaded part is 1/5 of the circle. All right, so why is that important? Because you're looking for an angle, right? So why is it important to know that? Well, remember, this part here is now going to come in handy. How many degrees in a circle? 360. So that means if this shaded part that I have in green, I'm going to erase this now, this shaded part that I had in green is 1/5 of the circle. That means that angle is 1/5 of the circle. So all you have to know now is what is 360, or 1/5 of 360, which is the same as just multiplying 1/5 times 360, and that is equal to 72 degrees. So that is your answer, 72 degrees. All right, we're going to go on to the next one. All right, let's look at problem 29 here. It says a machinist creates a solid steel part for a wind turbine engine. The part has a volume, so the first thing we see that's important is the volume of 1,015 cubic centimeters. Steel can be purchased for 29 cents per kilogram and has a density, that's our next keyword, density of 7.95 grams per cubic centimeter. All right, now the question is, if the machinist makes 500 of these parts, what is the cost of the steel to the nearest dollar? All right, so let's go ahead and make this happen. And so what I'm going to do now is have you guys write down this formula. You need to know this. So you have density equals mass over volume. So if you're looking for the density, that's mass divided by volume. If you're looking for the mass, it's density times volume. Right now, what we need to find is what do we need to find? We need to find the mass, actually, all right? Because we have the density and the volume. We need to find the mass. Now, a lot of times, people will say weight, and mass and weight are similar, but they're kind of different. I probably couldn't explain it that well. For the purpose of this problem, they're the same thing, because there's nothing about weight in here, but in the future you might hear it interchanged, mass, weight. They're actually a little different, but for this problem, they're the same thing. All right, but we need to find the mass anyway. All right, so what we need to do, so this machinist is making 500 of these parts. We need to know the cost of the steel. So in order to find the cost of the steel, we need to know how much steel that they need. And we need to figure out the mass to find that out. All right, so we're going to have density, so D equals, I'm going to just write again over here. And we actually have the density, so we're going to plug that in. So we're going to have 7.95 equals, our mass is what we're looking for. Our volume is actually 1,015 cubic centimeters. All right, and we are going to cross multiply, so we're going to end up with M is equal to 8. Once you do that, you get 8069. So 8,069.25 grams. So actually, once you get this answer, you actually have grams. You actually have grams. All right, because remember, the 7.95 is grams per cubic centimeter. So let's see, and the volume is cubic centimeters. So actually, the cubic centimeters cancel out, so you're left with grams. So actually, the number we get here is grams, all right? So now, that is in each part, all right? We just found that that's the mass of each part. Now, we need 500, so we're going to multiply that by 500, because we need 500 parts. And that's going to give us 4,003,4,625. So that's 4,000,000 4,034,625 grams, right? Now, the tricky part about this is that when they give us the price per unit, they give us price per kilogram, not per gram. So you don't want to just multiply this number by 29 cents, okay? Because this is how many grams. We need to convert that to kilograms. So there are 1,000 grams in a kilogram. So all you have to do is move the decimal over 3 places. Remember, 3 places would be the 1,000th place. So if we have this number, 4,034,625, right? If I move the decimal 3 places, we have 4,000. So this would be grams. And then it would be 4,034.625 kilograms. All right. Now, since we have the amount of kilograms, the mass in kilograms, now we can just multiply that by 0.29 or 29 cents per kilogram, and that is equal to the nearest dollar. Remember, to the nearest dollar, it's going to be $1,170. All right. So there we go for that problem. So we'll come back and do the last one. All right, so let's go ahead and look at this problem. It says, in the graph below, triangle ABC has coordinates, and they already have a graph for you, coordinates of A, B, and C. Triangle RST has coordinates, and they give you the coordinates. They already have a graph for you. And let's look at the question here. It says, is ABC congruent to triangle RST? Use the properties of rigid motions to explain your reasoning. Now, this question's a little different because they're asking you is. It's a question. It's not saying explain why. Many times that I've seen on these tests, it'll say explain why this triangle is congruent to this using the properties of rigid motions. Here it says is, so there's a chance that they're not congruent. So first thing we need to know, what about rigid motion transformations? Well, what are they? Okay, when you do a rigid motion transformation, the size and shape of the image is congruent to the pre-image, distance is preserved, the new, there are a lot of ways you can say it, but the new shape is always going to be the same shape and size as the old shape. All right, the image and the pre-image are going to be the same. They're going to be congruent. And the 3 that do that are rigid motion transformations are those 3. All right, now, are they congruent? Well, if they are congruent, all the sides should line up. All right, not line up, but be congruent. So AB, so if I look here, AB should be congruent to RS. So that would be this green one. AB should be congruent to RS, right? Right here, RS. I'm going to do that in green. You can tell by the letters which one should be congruent. Then BC should be congruent to ST. So BC should be congruent to ST. And AC should be congruent to RT. So AC should be congruent to RT. So first thing I did when I was looking at this problem, and I was like, okay, it looks like maybe it's a reflection, and let's just check that. So I thought, okay, it's probably a reflection over y equals x. So I just drew my line. This is y equals x, right? So I did that, right? Okay, then I counted, because remember, when you do a reflection like that, you have to count over and up. So I said, all right, so I looked at point T here, right? I'm going to do it back here. I looked at point T right here, right? And I said, okay, let me count. 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. Okay, that's good. And then I looked at point A, or I'm sorry, R. And I started R, and I said, all right, 1, 2, 3, 4, 5, 6, 7. Over 1, 2, 3, 4, 5, 6, 7. Okay, so R and A are good. Then I looked at S and I said, all right, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Then I realized, okay, S and B are not lining up. So these don't, either I made a mistake or these are not congruent. So then I said, all right, well, let me just find the lengths of all these sides, or let me, because I'm concerned about this one in blue. I'm concerned that these are not the same length. If they're not the same length, then these are not congruent. So what I did was, all right, I'm going to find the length of those sides. So I found the length, or I'm finding a length. What I did is just make a right triangle from B to C and from T to S, right here. And now this side is going to be 3, this will be 4, and this is going to be the hypotenuse. You could use the distance formula to find this side, or you can use this method I'm showing you. So this would be 3 squared plus 4 squared is equal to C squared. This would be 9 plus 16 is equal to C squared. 25 is equal to C squared. So C is equal to 5. So our BC is equal to 5. All right, now, what about TS? Because BC and ST need to be the same length, or else these triangles are not congruent. So here we have 3 and 3. So, and we have C, so that's going to be 3 squared plus 3 squared is equal to C squared. And then we have 9 plus 9 is equal to C squared. 18 is equal to C squared. And C is equal to the square root of 18. So that means that ST is equal to the square root of 18, which is not the same as 5, which means these triangles are not congruent. Okay? So we know it's no. Now we have to explain it. So let's explain it. All right? So this is what I wrote. All right? We already did work. And so no, since the lengths of side BC and side ST are different, there is not a rigid motion transformation that will map one triangle onto the other. So there's not a reflection, a rotation, or a translation that's going to put one triangle on top of the other. It's not going to happen because they're not congruent. Okay? So that's your answer there. Make sure and write these down. And next time we'll be going over a couple more. All right?